All right, so 2.2, number 9, says use powers of 10 to write each number. So remember what a power of 10 is? A power of 10 would be 10 to the 1 or 10 to the 7 or something like that. So we want to use powers of 10 to write these numbers. And if you recall from the notes, let me see if I can go back a little bit. Yeah, here's the notes that I gave you last day. This is how we use, see, the powers of 10 here? This is how we use powers of 10 to write numbers in standard form. So that's the pattern. So let's just go over a couple here. So this one is 6 followed by 9 zeros, okay? So this is thousands, millions, billions. So 6 billion. This is 6 times, and you can use the X here for times. I don't mind. That's the pattern they use, so that's totally cool. And we have to use some power of 10. So 6 times what number should I put up here? 10 to the 9, exactly, because there's 9 zeros. Awesome. Now, are there any other numbers other than 0 in this number? No. So that's it. So for A, we're done. That's it. Okay? Let's do, B's pretty easy. Let's do C. C's a little tougher. Look at all these numbers. Wow. Well, what you got to do is you got to take a look at the positions that each digit occupies. And when I say digit, I mean digits are numbers. The position would be like what power of 10. So this 5 is in the ones spot. This 1 is in the tens. This 4 is in the hundreds, and so on, right? You guys remember all this? So this 1 is in the thousands, and this 5 is in the 10,000s. Okay. So if you remember how those work, it's really easy to go, hey, ones is 10 to the, oh, what's the power on 10 for 1 again? Is it 10 to the 1 is 1?
No, 10 to the 0 is 1.
10 to the 0 is 1. Very good. The tens, 10 to the what is 10? 10 to the 1. 100 is 10 to the 2. 1,000 is 10 to the 3 and 10 to the 4 and so on. So that's how we start to build this. Now, there are 5 10,000s in this number. See? 50,000. So there are 5 10,000. So I start by saying 5 times 10,000, which is 10 to the 4. Good idea to put those in brackets so you can separate your work a little bit. It's all neater. Everybody knows what's going on. Now I need to account for this 1. So we have a 50,000, and this is a 1,000. It's in the 1,000 spot. So this is 1 times 10 to the 3. Okay? So we've got the 50,000 taken care of. We've got the 1,000 taken care of. I need to get this 400 taken care of, and you guessed it, 4 times, how do I write 100 as a power of 10? 2. 2, right? Okay, good. And we just keep going on. So we're going to do 1 times 10 to the 1 plus 5 times 10 to the 0. So that's kind of a long answer for this long number, but that's how you do that. Okay, shall we do one more? Shall we? Oh, shall we? That seems so formal, doesn't it? So 14th century. Oh. Okay, let's do one in red. I like red today. Which one, D, E, or F do you want me to do?
D.
D. That was a very definite D there. Okay, let's do D. D. All right, now it might be easier to start on this side and work this way. That's not the format here. It's not the format, but we could write it that way and then switch it around. But I tell you what, let's do this way. Let's figure out what the 6 is, because that's one we should write first. So this is 10 to the 0, 10 to the 1 spot, 10 to the 2 spot, 3, 4, 5, 6, 10 to the 7. So this 6 should be 6 times 10 to the 7. So once again, start at 0 and then count. 1, 2, 3, 4, 5, 6, 7. That's how you do that. And I'm going to now add, so do I have to write this 0 times something, or should I leave that out, or could I leave that out? No, I don't have to write it? Okay, let's go back to our notes here. Oh, look at this question. Remember how we didn't write these zeros? So we didn't have to write those up here. The times 10 to the 2, times 10 to the 1. Didn't have to write them if there were zeros. So let's just skip that 0 then. That's no problem. So I'm going to go 7 times 10 to the What spot is that? 5? 0, 1, 2, 3, 4, 5. Okay? You guys with me? It's a little quiet here. Are you guys with me? Is this making sense?
Yeah.
Okay. Now what I could do is I could do another step before I get to this last one, and I could write out the actual, 10, 100,000, with all the zeros. If that helps you, you can do that as well. But so there's another 0 we don't have to worry about, but let's take care of this 2. So we're going to add 2 times. Now this is 10 to the power of 3, isn't it? Because it's 1,000. So 2 times 10 to the 3. Skip the other 2 zeros, plus 8 times 10 to the 0. So 6 times 10 to the 7. So let's say this would be 6 followed by 7 zeros, right? Now does that make sense? 60 million. Yeah, this number is definitely 60 million and something, right? So we're good. You see how that 10 to the 7 would be 10 million? So 60 million, that's good. This 7 should be 700,000. 700,000 there. So is 10 to the 5 100,000? Let's see. Yep, that's 100,000. So that's 7 times 100,000. Any other questions about that? Is that making sense? So this is your answer. It looks like there. Okay, I will let you go ahead and tackle the rest of those on your own, and let me know if you have any problems with that. Okay, I'll get you started on number 11. Okay, I have a question about number 11. So it says here, the data below refers to trees in Vancouver. Use powers of 10 to write each number. Okay, so the number that's given in this statement, street trees have an estimated value of over 500 million. So this is the number in question, and we want to write that as powers of 10. So similar to number 9, but what we have to do is write that as, this is going to be 500 million. You might want to write that out fully in standard form first to see exactly how many zeros we have. And again, the first 3 would be thousands, then the next 3 would be millions, whoops, and the next 3 would be, what did I say? Thousands, wow, 500 million. So I definitely don't want, yeah, that's right. This would be, oh my goodness, 500 million. So this is 1,000, this is a million. Yeah, this one would be a billion. So we're not in billions yet. That's 500 million. Right? Agree? Yeah, 500 million. So that's what that one is. It's 500 millions. So if we had 1 million, it would look like this. If I multiplied this by 500, so times 500, then this 1 would become a 500. And that's that's good. Okay? So then, if you write it out like that, then it becomes a little bit easier. So then this is, 5 times 10 to what power? Well, you basically just count the zeros, I guess. Right? So what's that? 3, 6, 8? 5 times 10 to the 8, looks like. Does that make sense? Yeah? Okay with that? Next one, in the past decade, the park board has planted almost 40,000 new trees, 40,000. So that one's pretty straightforward as well. Not too complicated. That's going to be 4, because it's not a 1, so it's 4 times. What power of 10 would that be? If this was a 1, this would be 10 to the power of what? 1, 2, 3, 4. Perfect. 10 to the power of 4. Okay. Units, as far as units goes, I guess you could put your units there as final answer, because the units are involved. So, your final answer might look like this. There's no units for trees. It's just a number, so you can just put like that. So there are some more questions for number 11 there, but that should give you a good start, okay? I'll let everybody else have a go at the rest.